All right. If no question, we move forward. Okay, move forward. Using chi-square to do association or correlation. This happened a lot, and a lot of questions asked for the qualitative research or survey, social science. Okay, and we may ask, oh, your job, you take exam to take this job because you live close here. Okay, you come to work here because your hometown is here. So what I said, there are two variables embedded. So the first one is job, and the second one is, what is it? I state it again. You come to work here because your hometown is here. So there are two variables in what I said in the statement I made. So the first variable is what? Is what? Job, right? Job category. Yeah, good. Yeah. So the first one is job. For instance, a teacher, okay, a policeman, okay, a lawyer, or whatever. Okay. And the second one is birthplace. Birthplace. Yeah. And there are many occurrences or many cases that they ask whether the job you take or the job you chose, is it depend on your birthplace? Okay. Or the job you chose to work depends on the population, or let's say some people really want to work in the city rather than in the remote area, right? So these are more or less qualitative. And if we want to see whether there is an association between two qualitative variables like this, we can also do the chi-square. And our research question, our research objective hypothesis, the principles are more or less the same as those written for the quantitative. Okay, the principles are the same. The difference is just the nature of the variable, meaning that one group is quantitative and another is just qualitative, all right? Or let's say the government set our goal that some of the job must be reflective of the degree, okay, the degree. It means that the job title is associated with degree, all right? So this is qualitative data. When we look back to our data, car 93, right, we want to ask, for instance, is the airbags of the car associated with the origin it was made or not? Some people say, oh, the American people, they really want to be safe when driving the car along the road. Then all the cars that made in the US must have the airbag, at least for the driver, because many workers, many governmental staff, they drive alone. But for the car made out of the US, for example, from China, from somewhere else, or they just make the car in order to help us, okay, moving from one to another. So first, the aim is to transport us rather than safety. Okay. Then we want to ask whether the purpose of embedding the airbag into the car is dependent on the place where it is made or not, right? Okay. Okay, so here for the data car 93, we may ask or we want to say, we may ask or made a statement, test a statement, so test a statement. Okay, the car made in the US is built with airbags. Okay, with the airbags. Or we can say the airbags inside the car. Okay. Airbag inside the car is placed, or is what? Is inserted or is built? No. Is what?
Made.
The airbag is made? Yeah. It's made. Okay. the airbag inside the car is made depends on where they are manufactured. Okay, let's say in the in or out of the US. Okay, so we want to test this statement. Okay, the statement that all the airbags inside the car is made depends on where they're made. If they're made in US, then most of the car have the airbags. Where the car made out of the US, there's no airbag. This is one statement. So we want to test whether this statement is supported by our data collected or not. All right. So the statistical hypothesis, the H0 statistical hypothesis is what? If you remember the hypothesis made for the association analysis for the quantitative variable, then you can also do this one. Anyone would like to try? Okay, please. H1 and H0.
Is there any significant difference, sir?
When we focus on association, we don't include different or no different in the hypothesis anymore. We don't include.
Okay.
Right. Different or not, it's just for comparison. Yeah, but here it's not about comparison, it's about association and correlation. So, or you can say here, the keyword depends. Okay,
there's no
dependent.
significant association or correlation
Yeah.
between the air.
Right, there is no significant association between the origin of the car and the airbags made. Okay. Yeah, good. Airbags made. Okay. Or you can say, okay, the airbag made inside the car is not dependent on where they are made, or where can say another. Okay. Or you can say, so we can change the phrase, but the meaning is the same, right? So the okay, you can just copy. Okay, the airbags, or where is it? The right, the airbag inside the car, made inside the car is not okay, dependent on right
where they are manufactured.
Right, dependent on where they are manufactured. Okay, yeah. So the meaning they are the same, right? You can say there's no association between the origin of the cars and the airbag made inside the car. Okay, or you can say the airbag made inside the car, okay, is not dependent on where they're made. Okay, whether in the US, in the Asia, or in Europe, they care for safety of drivers and passengers. So they must install all airbag, something like that. Okay, and the H1, yeah, you can do it yourself. Okay, now doing the test, pi square the same with the function. And the first we need a table. The first table, df origin. Okay, you can put anyone first. Okay, no matter, no problem. And then table. So this is two variables. Okay, the first variable and the second variable, airbags. Okay, I think more or less. Okay, right. So there's some errors or no errors. Okay, it must have the same length. Table df origins. Why there's difference? So 48 in here, and so why there's not different x and y? Oh yeah, okay. So you don't need table because it needs to assign from one to another one. Okay. All right. So we can do a run here. Okay. So you can see here Pearson chi-square test. Okay, Pearson chi-square, or we can say Pearson association. Data origin. Okay, and a p-value. Okay. You see that any dependent between the two variables? Any dependent?
Yes, sir.
Not dependent.
Is yes.
Not dependent greater than 0.
Right. So do we accept or reject the null hypothesis? So
Accept,
the p-value,
null.
right. Okay, so we accept the H1, meaning that there is no, there's no association between the origin of the car and the airbag inside, meaning that whether they are built in the US or outside the US, the airbags are installed equally prioritized statistically. Okay, it means the manufacturers, they care for the safety. Okay, after some period of time, in a very old time, the first stage of car development, maybe there's no bag, but afterward, okay, across the world, they think about the safety, right? That's why they put the they put the airbag inside the car. Okay, all right. So you can do any further tests, okay, to qualitative variables. Okay, 2 qualitative variables. Then you will see. Okay. Question? No? Okay, if no, okay, good. Please think of 1 or 2 variables, okay, in order to practice for comparisons and for the association using the qualitative variable. After the break, I would like to ask some of you to present or to show the first test, comparisons, and the second one is the association. All right? Okay, so let's come back by 11:50. Okay, 11:50. So now, please, anyone, okay, anyone, please share the screen and do practice for the first chi-square, doing the comparison, and the second, doing the association. Okay, please, anyone would like to practice the first one, and then the second one, another person. Okay, volunteer. Volunteer, please. No?
Sir,
Okay, Brian. Yes, go ahead, Brian.
is my screen, sir?
Okay,
Visible?
yeah.
Yes.
Yeah.
Okay, so this is my practice on the comparison. No? I use the variable drivetrain.
Which variable?
Drivetrain, sir.
Okay, okay, good.
Yeah, this is the data for the drivetrain. So it's a table, sir.
Mhm.
The actual frequency is that for forwarders, we have 10, front 67, and rear is 16.
Mhm.
And I just use the expected distribution of 1/3.
Okay, yeah.
Just like
Yeah,
before. And then this is the
Okay.
chi-square test.
Mhm.
So we have the p-value of 1 raised to the -14, which is a relatively small, no, compared to
Okay.
the p-value of 0.05.
Okay.
And this is our bar plot.
Yeah.
That's right. This is a Yeah.
Yeah, very, very different. Yeah.
Yes, sir. So based on these values, we accept the HO, meaning that there is no, I mean the H1. There,
There is.
there's a significant difference
Yeah.
between the airbags and, I mean, the drivetrain, sir. Yes.
Good. And can you use another example?
Using comparison, sir.
Yeah, yeah.
I have also the association, sir. This one.
Mhm.
So on my association practice, I use the variables, the airbags and the type of the car. So my now
Mhm.
hypothesis is that the airbags made inside the car is not dependent on the type of the car.
Okay.
Knowing identifying the type of the car, we have 5 types of cars from compact,
Mhm.
large, mid-size, small, sport, and van. And using the
Yeah.
chi-square test, this one, sir, we have the p-value of 0.0000, which is smaller than 0.05, meaning the airbags inside the car is not dependent on the type of the car.
Mm. Wait. So here, yeah, there is, yeah, because the p-value is very small.
Yes, sir.
Is it? Yeah. Everyone, you get this point? So it is not accepting H0s, accepting. You see the p-value is so small, right? So if the p-value is less than 0.05, then we accept the H1, right?
Yes.
So there is.
There is no. It is not
Or
dependent, sir.
perhaps, yeah, perhaps you follow what I wrote in my code. So my code, I also say accept H1 is not accept H0 because the p-value for the origin in the airbags is 0.78, right? And I accidentally wrote the accepting H1, but actually it is not accepting H0. Okay, but here in your case, because the p-value is so small, okay, less than 0.05, then you have to accept the H1, meaning that there is a significant relationship or significant association between the airbags and
The type of the car.
the types of the car. All right. So in order to have a plot that we can see, in particular with the association, something like that, we can see. Okay. So here, line 48. At the end of the class, I wrote accepted H1, which is wrong. Okay. I just corrected it to H0, accepted H0 because the p-value is so big. Okay. But for the
Okay.
type, for the types of car that Brian just did with the airbags, there is a significant difference. Okay. So here, airbags and airbag between origin, airbag origin. So let's see here, C bind, then DF table, DF origin, or let's say airbag first, airbags. So airbags here, how many of it? Oh, there's just only 3, and then origin. So if we do the plot here, I'm not sure if that work. Bar plot, it does not work with this correction. Bar plot. We need to rearrange the data in order to see to find the box plot. Okay, or you can do a search on the Google. Okay, like how to do Pearson correlation plot chi-square. Pearson correlation plot in R. Okay, there is many helps from the online. You can always ask. Okay, it is helpful in this way. So this is different types of plot. Okay, so the bigger size indicate the bigger strength of the Pearson correlation coefficient. Okay, so you can do the mosaic plot here. It is also a very nice one as well. You you install the library graphic. Okay, and then the DT, the data, the DF here. So DF here, what we need to see the DF from here. As table matrix. Okay, house tag, house task. So the house task here, you can see here, wife and laundry, something like that. HG, okay. So mosaic plot. Okay. So we can do the plot. Doing the plot. So library graphics. Okay. It's already there. And then I can ask what a mosaic function is. And here you have X. So we can see X with the example quick. Okay. Mosaic gear. Okay. Crabs. Mosaic gear. So this is start, the base start is okay. And Titanic. You can see here the Titanic car. Oh no, Titanic data. Okay. Just run here. It is a mosaic. There is sex and is an age. Okay. Age, adult, child. Okay. Yes, no, something like that. And many different others. Help here. And this mosaic hair colors. Okay. Shaded truths. Okay. A lot. Eyes and hair. So hair color. What is the data frame here? Let's see here.
Right, John.
Hello. You hear something? So this is a lot of see here, a lot of variable, a lot of categories. Let's see some category which is small. Some practice. So this is gear and this is carb. So we can see, so empty car. Okay. So empty car, we have empty car, age, sex. Okay. So empty car, where is sex? No, gear and carb, gear. Okay. So gear and carb. Okay. Mazda. Okay. So we need a confusing matrix. Table DF, airbags and DF origin. Okay. Okay, so here we have already. So this is what we can do. So mosaic plot. Not sure if this is work. It would work. Okay, you can see already. So driver and passenger, you see the distribution. Okay. So if we see the upper panel from the left to the right, the proportion are more or less the same. Okay, are more or less the same here. Okay, it's like 1, 1, 1, and the same as the non-US car with the drivers. and driver only, and none. Okay. Yeah. So mosaic plot here. So chi-square test. We have seen this already. It is the p-value here. Okay. These are the associations. All right. Okay. And for Brian did at the moment, it is chi-square. What is the name of the variable? Brian? Brian, what is the variable name?
Type, sir, and origin.
Real type. What's it again? Type, eh? Is it type?
Yes, sir. Type.
Okay, type, yeah. All right. And then with
Green
the,
at origin, sir.
excuse me? Excuse me? All right. Yeah, so there's a significant p-value here. Okay. So p equal this value, which is small. Then we accept H1. We're doing the
H1.
plot. Okay. And mosaic this one. Mosaic plot table. Okay. What? Okay, yeah. Okay. So you see that, okay, some of the van here, okay, some of the van has only none. Most of the van is none. You see that? And maybe 30% are, by the way, please have a look at this. It is good to see for you as well. Yeah. Oh, say this one. Okay. So the vertical line, there must be three category. For the compact car, okay, what is the largest proportion of airbag? Compact car.
Drive.
Yeah, only driver. Yeah, maybe 50% something, right? And the smallest is driver and passenger. How about large car? What is the smallest or almost no category of airbag observed? Here, the below one.
Drive. Nine.
Yeah. So here it is none. So for all the large car, there is almost no car with no airbag. Meaning
Airbags.
that, yeah, all the large car, there must be airbags. Majority is for driver and the other list is for passenger. Okay. How about van? To the right one.
Driver and passenger.
Yeah, no, the majority is here. What? Here? What
Minus.
correspond to?
I think
Yeah?
that's none, sir.
Yes, that's right. That is none. Majority is none. And here, what is it?
Driver only.
Yeah. How about driver and passenger?
No
Yeah.
airbag.
Right. It's almost zero. The airbag with for drivers and passenger almost zero for the van. Okay. Mostly it has for driver and the majority there's no airbag. All right.
No airbag.
Yeah. And for small car, most of them have no.
Airbags.
Yeah. Has no airbag at all. Most of
And-
them.
Yes.
To some amount, maybe 25%, there are airbag for just driver, right?
Driver. Yes, sir.
Yeah, for the car that have both driver and passenger, none, almost
None.
zero. Yeah, you can check, right? You can check
Yeah.
with this one, the smaller. All right, so this is a good plot that we can see. All right, okay. All right. You can also play around with the other many variables that you're interested in, and you can also think of this kind of test when you do your own data collection, right?